Would it be chemistry without titrations? Probably not. So we need to know how to do calculations related to titrations. Now, what is the point of a titration? Well, it depends on what you're looking at. It could be to make a soluble salt, but it could be, in this case, to identify the concentration of an acid or an alkali. If you know the concentration of volume used of one substance and you neutralize it with another that you don't know the concentration for, you can use the balance symbol equation to figure out that concentration. So let's go for it. So here we have got a student with a sample of hydrochloric acid and they don't know the concentration of that hydrochloric acid. They've done a titration. They've found that you just need 11.8 centimeters cubed of the acid to neutralize 25.0 centimeters cubed of 0.200 mole per decimeter cubed sodium hydroxide, or NaOH. And that's enough information for us to calculate the concentration of the hydrochloric acid. So how is that? Well, the first thing I'll do is I will write the formulae of the two substances we're interested in, hydrochloric acid and sodium hydroxide. And then what I'll do is I'll essentially construct a table where I'm going to put in all the information I know. So concentrations, volumes, but then I'm also interested in the number of moles and in the molar ratio. Okay, so this relates to the balanced equation. Okay, so now I'm just going to fill this in with the information that I've got. So the concentration of HCl, I don't know this. That's what I'm trying to figure out. I'm told here that I've got a volume of 11.8 centimeters cubed of hydrochloric acid. So I'm just going to write 11.8 centimeters cubed next to the volume. And I'm told that we've used 25.0 centimeters cubed of NaOH, sodium hydroxide, and that the concentration of the sodium hydroxide is 0.200 moles per decimeter cubed. So I want to find this value. I need to give my answer to three significant figures. There's all the information I have. Now, if you haven't already looked at question 3 on this resource, I'd recommend you do so because that talks through concentration and you do need to know how to calculate concentrations in order to do this question. So concentration, if it's given in this unit here, moles per decimeter cubed, it can be calculated by doing the number of moles divided by the volume. Now you'll notice in the right hand column of my table under NaOH, we've got concentration, we've got volume, but we don't know how many moles we have. That's what we want to figure out. So we are going to need to rearrange this equation in terms of the number of moles. So if I multiply both sides of the equation by volume, what I end up with is concentration times volume equaling the number of moles. So to get this value here, I'm going to have to calculate the concentration multiplied by the volume. However, before I do that, there is a slight catch, and that is that my volume has been given to me in centimeters cubed, so I must convert it to decimeters cubed in order to do my calculation. Now to do that, we've said already that we need to divide the number by 1000, and that will give us 0.025 centimeters cubed. We can also do the same with the 11.8 centimeters cubed because we are going to need to convert that into decimeters cubed later for when we use it, so I might as well do it now. So dividing that by 1000 gives us 0.0118 decimeters cubed. And again, that should be decimeters cubed down there. So corrected those errors, easy to make, okay? But now what we need to do is actually calculate the number of moles. So we need to do this value here, 0.200 multiplied by 0.025. And if you do that, you get an answer of 0.005 moles. So we know how many moles of sodium hydroxide we've got. Hooray, great. What does that mean? Well, when you do a titration, you add the acid until the alkali neutralizes. So until you see that endpoint in the indicator showing that you've got the exact volume of the acid required to neutralize the sodium hydroxide. Now that's important because it tells you that, okay, if that's your balanced equation, you've got the exact number of moles of hydrochloric acid you needed to neutralize the exact number of moles of sodium hydroxide you had. So If we've got 0.005 moles of sodium hydroxide, and if we look at the ratio of the balance symbol equation, there's no big numbers there. It's a 1-to-1 ratio. So for every 1 mole of hydrochloric acid that reacts here, it's going to react with 1 mole of sodium hydroxide, which means if we've got 0.005 moles of sodium hydroxide, it's going to react with 0.005 moles of hydrochloric acid. Good stuff. So now we've got the number of moles of hydrochloric acid, we've got the volume of hydrochloric acid, we can calculate the concentration by using this equation over here. So the concentration of hydrochloric acid will be the number of moles, 0.005, divided by the volume in decimeters cubed, which is 0.0118. If you do that calculation, you get an answer of 0.4237288, and then a load of other numbers, moles per decimeter cubed. But we need to give our answer to 3 significant figures. The third significant figure here is the 3, because remember, if you've got a 0 preceding the decimal point, that does not count as a significant figure. It's the first non-zero digit of your number. So the first non-zero digit is 4, the second is 2, the third is 3, and then we need to look at our fourth digit. Is it greater than or less than 5? It is greater than, so we need to round up. So therefore, to 3 significant figures, our concentration is 0.424 moles per decimeter cubed. Now you might be thinking, what do you get the marks for here? Well, you get a mark for getting the right number of significant figures at the end. You get a mark for calculating the number of moles in this step here. You get a mark for realizing it's a 1-to-1 ratio just here. And you also get a mark for doing the calculation just here. So 1 mark for finding the number of moles of sodium hydroxide, another mark for finding the moles of hydrochloric acid. The third mark is for doing the concentration of hydrochloric acid, and then the fourth mark is for getting the right number of significant figures for that question. There is another example of one of these questions, so 4HB, and that is here. Okay, I'll have to apologize just with the balanced equation. That should be a small 4 there. I am very sorry about that. So here is the question. What we need to do is we need to do or find the concentration of sulfuric acid this time. So sulfuric acid is H2SO4. So once again, I'm just going to write the identity of the 2 reactants at the top of my table, and I include the balancing numbers to make my life a little bit easier later on. So concentration, then volume, then number of moles, then the ratio. So let's have a look at the numbers I've got. So I'm told that we've got 32.7 centimeters cubed of the sulfuric acid. So I'm going to write that there, 32.7 centimeters cubed. Note it's in centimeters cubed, so we're going to have to convert that into decimeters cubed in just a moment. And then what else have we got? We've got that it's 25.0 centimeters cubed, once again, of the metal hydroxide. This time it's potassium hydroxide, and the concentration is 0.800 moles per decimeter cubed. So first things first, let's convert those 2 values in centimeters cubed into decimeters cubed. We need to divide that by 1,000, so we get 0.0327. Divide this by 1,000, we get 0.025. And then we need to find the number of moles. And remember, concentration is equal to moles times vols. So therefore, in order to find the number of moles, we need to rearrange by multiplying both sides by the volume, which means concentration times volume is equal to the number of moles. So if we do 0.800 multiplied by 0.025, we get an answer of 0.02. That's the number of moles of potassium hydroxide that we have. Now, if we look at the balancing numbers this time, we've got a big 2 in front of the potassium hydroxide. no balancing number in front of the sulfuric acid, which means that for every 1 mole of sulfuric acid, H2SO4, that is reacting, it's going to react with 2 moles of potassium hydroxide, KOH. So it's a 1 to 2 ratio. So 1 to 2. So that means that if we've got 0.02 moles of potassium hydroxide reacting, then the number of moles of H2SO4 that's reacting must be half of that, 0.01, because of that 1 to 2 ratio. So now we've deduced how many moles of sulfuric acid we have. We've deduced the volume of sulfuric acid that we have. So what we can do is we can find the concentration by doing the number of moles, which is 0.01, divided by the volume, which is 0.0327. And if you do that calculation, then you get an answer of 0.30581. And a load of other stuff. Put to 3 significant figures. The first significant figure is your 3. The second is your 0. The third is that 5. Is the 8 greater than or smaller than 5? It is greater than 5. So therefore we round up. So our answer to 3 significant figures is 0.306 moles per decimeter cubed. Now once again, in terms of the marks, where they're coming from, similar story really. 1 mark for getting that you've got 0.02 moles of the potassium hydroxide. Another mark for realizing it's a 2 to 1 ratio, so finding 0.01 moles of the sulfuric acid. Your third mark is for calculating the concentration by doing moles over volume of the sulfuric acid. And then your final mark is for getting the correct number of significant figures. Make sure you read that question carefully, because that is a mark you do not want to drop. Thank you very much for listening. Hopefully that has made titrations a little bit more comprehensible.